let's make a visual representation of an electromagnetic wave. And so if you have an electromagnetic wave, we have an oscillating electric field and a magnetic field. I'm just showing the electric field right here. And on top of that, so I want to represent this as a three-dimensional space thing. And I'm going to display the values of the electric field along here. And then I want them to change with time too, right? So if we have this as the x direction, I'm going to make my wave in the x direction. I can make my electric field in the y direction. And then I'll make my magnetic field in the z direction. But I want to represent, I can calculate the magnitude of the electric field, which I'm going to represent as arrows at every point along here as E as a function of x and time. It's going to be E0, the maximum electric field, times the cosine of 2 pi times the frequency times the time. That's going to be the time varying part. And then I have minus 2 pi x over lambda. That's the spatial part. So that's using both of those together, it will change in both time and space. Now we just need to make that happen in Python. And we're going to have these arrows, and they're going to change with time. Now, I want to do light, but it's not going to move with the speed of light. I'm just going to use some fake numbers just so it'll look good. I want to make something that looks good. So let's jump over here to Web VPython, and it's going to be great. Now, there's a bunch of stuff that we're going to need to do here because we're going to deal with calculating the electric field. We're going to deal with drawing arrows for the electric field. We're going to deal with putting a bunch of arrows, right? I'm going to have a bunch of arrows, so I need to deal with that. I'm going to put all these arrows into a list. Let's get started. Okay, so I'm using Web VPython. I'm going to give you the code at the end. I'm just going to go ahead and pick some parameters. So I need to know the wavelength. I'm going to call that lam. I think lambda is reserved, so I'm not going to use lambda. Is that big enough? A little bit bigger? Okay. The frequency, 1, not surprising. And then I need the maximum electric field. And so since I'm drawing these as arrows, my electric field is going to be a distance. You know, I could put a scaling factor in there, but I just want to use something that makes sense. So I'm going to put E0 equals 0.2. So, you know, a wavelength of 1, and then the height will be 0.2, or the total will be 0.4. We can change these. It's not a big deal. We can change it. That's why I put it as a variable. And it still seems a little small, but I'm going to go with it. Okay, so now what I want to do is to make a list. And this is going to be my arrow list. And I can add my electric field arrows into that list, and they're all going to have a different position and everything. And that way I don't have to have, 20, 30, 40, 50 electric field vectors to deal with. It's just one list. So my list I'm going to call EA. A is for arrow, and it's going to be an empty list. Now, a lot of times I like to make an empty list and then add things to it. If you don't make the list first, you can't add to something that's not there. Okay. I need my starting x value, my final x value, my x step. I'm going to break it into steps. So I'm going to say I want to go from -2 to 2. So x equals -2. And I'm going to pick a step size dx of 0.1. And this is too small. That's better. 0.1. So, and again, we can change those things. That's how the distance between each electric field arrow. I'm also going to need time, and I'm going to need a time step of 0.01. Let's just pick. Okay. So the first thing I want to do is I'm not going to change time right now. I just want to make all my arrows. So let's do that. So I have x is -2. I can say while x is less than 2, do the following. And then I'm going to go ahead and put x equals x plus dx. If you don't put that, you're never going to get to x greater than 2. So I'm going to move my x value until I get there. I put that first because if I forget, I get an endless loop and I just feel embarrassed and all that stuff. Whatever. Okay, I'm going to go ahead and calculate the magnitude of electric field at that location, right? I'm all at t equals 0. I haven't changed time. They're all t equals 0. So I'm just going to say E0 equals, E equals E0 times cosine 2 times pi times f times t minus 2 times pi times x divided by lambda. That's the same equation that I had before, right? I just wrote it in there. Now I want to add an arrow to my list with that electric field for each x value. So I'm going to say EA equals EA plus, and this is how I like to add things to a list, but whatever. And I'm going to add an arrow object. So arrow objects have two important points. Number one is the position. The position of an arrow is the starting point. And then the other property of an arrow is axis. Axis is the distance, the vector from the start to the end. Okay, so my position is going to be where I am in the x coordinates. So I'm going to say this, arrow position. And so you notice I'm not giving it a name because I don't care about the name. It's just an object in this list. Position is going to be that x value. So it's going to be vector x 0, 0. I'm going to keep it on the y and z plane of 0. Now I need my axis. It's just going to be E. That's it. Okay. Now I do want to make it. Let's see. Give it a color. I'm going to give it a color. So I'm going to say color equals color dot yellow. That's it. I got my closed thing and I'm adding it to the list. And then I'm going to increase my value of x and I'm going to do it all again. So this, if I just run this, it should make a static field, right? Up and down. And we can see what it looks like. It didn't look like anything at all. Axis must be a vector. Oh, you know what? I see what I did. That's fine. Mistakes are part of the learning. So I put axis as E, but E is a scalar value. So I need to tell it is a vector. So I want that in the y direction. So let's put this as axis is vector 0, E, 0. And there you go. There's my electric field. It's not moving yet. And I do want to fix one particular thing. So these arrows, they're scaled so that when they get shorter, they get skinnier. And I want them to all be the same width. So we can set a property in the arrow called shaft width. So if I go over here and I go down, where am I? I should save it, shouldn't I? Let's call this EM Wave 1 save. And I'll give you the link to the code. Okay, so I'm going to add over here. You don't have to put it at the end, but I'm going to. Shaft width equals 0.02, I think is a number that I used before, and it seems to work. So let's run this. And there. So now you'll notice they're all the same thickness. So some of these are just really short. And that looks really nice. You can see the nice wave property. If I want to get them, if you want a different wave, you want more arrows, just decrease the value of dx. You may need to decrease the shaft width. You can change all these properties yourself. But now what we need to do is to model it moving. I want to move it too. Okay, so that I already have the waves. I can go through and adjust their height. And that's what I'm going to do. So let's go down here and say, I already got that. Now I'm going to do a time loop. While t is less than 5, rate 100. So if you don't remember, rate tells the program, do 100 loops per second. So a smaller rate makes it run slower. And so that's something that you may want to adjust. And you could do it for 5 seconds or whatever. That can change it to. So what I want to do is to go through every point in the loop. I know its x value and I know time, and I'm going to redo what I did up there. But now time's changing, which I need to do right here. T equals t plus d, because I'll forget and I'll get back up there and it'll never change. So I'm just going to recalculate E, and I can just use the same thing. Except that I can't. Because x is just one value. It's at 2 right there, and I don't want to use x. So what I really want to do is this. Let's do this. For ET, temporary electric field arrow, in EA, I'm going to go through each one in the list. And they all have their own individual x value. So I'm going to put this tab indented, and I'm going to, ET is my arrow, right? And the arrow has a position, and the position has an x value. So instead of x, I'm going to say et.pos.x. That is my x value. So each of them have an x value. And the time is the time, and that's fine. Now once I calculate the arrow, the E value, I need to change the axis of each one. So I can just say et.axis equals E times vector 0, 1, 0. Or vector, no, that's right, like that. Or it could have said vector 0, E0, same thing. And that's it. So then I'm going to go through all of those. I'm going to update the arrows. I'm going to update time and do it all again. Let's see if it works. It might not work. You know, I make mistakes all the time. Oh, I didn't make a mistake. Doesn't that look nice? I can rotate around. That's just cool. That is cool, right? Okay. Let's include a magnetic field too. So E cross B is the direction of travel, and I'm traveling in the positive X direction. So I'm going to go up here. I'm going to add a B0 equals 0.2. I'm going to have the same length. You don't have to, but it's all what you want. I'm going to add a list for magnetic fields. BA equals an empty list. That's fine. And now down here, when I make my E's, I'm going to make my B's. So I'm going to just put this right here. B equals, it's the same calculation, except it's with B. And then I'm going to add it to the list. It's the same as this, almost. Control C, Control V, dedent, change to B, change to B. That's fine. Axis, now I want that in the Z direction. So I'm going to change this to 0, 0, B. And I don't want to put it yellow because then you have two and everybody knows that the magnetic field and electric field are different colors. Everyone knows that. I like cyan and magenta, and I'm going to go with magenta. Why? What did I do before? I did this before. I did go with magenta. Okay. Magenta. Okay, there, it's different color. Now, down here, when I update my electric fields, I need to also update my magnetic field. So I'm just going to copy that and paste it. Why type stuff if you don't have to? I'm going to dedent. I'm going to say BT. Then I use T for temp, right? That's B. That's B. ET is BT. And then this is, now I want this in the Z direction. And this is B. And this is BT. And let's run that. And it broke. Color must be a vector. What the heck did I do? Magneta. Magenta. That's how you spell it, right? Oh, I messed up. They're both in the Z direction. What did I do? Okay, that's in the Y direction. That's in the Y. Ah! That's why. There we go. Nice. Super nice. I mean, come on. That's not physics, that's art. But you know, here's what I love about that. I love that I can make this really cool visual that I could use for teaching or whatever, or for a blog post or for a video. But it's also got a lot of physics in the building of it. It's not just an artistic thing. It's a building thing. Now, I don't know if you know where this is going, but I want to use this to show the interference of two light waves. And I'm going to have to change stuff up a bit here. Because what if I want to not be in the X direction? What if I want to be aimed at some other generic direction? Then what do I do? Well, I want to pick a point to start at and a point to finish. Okay? And so I'm going to use that point in there to tell me where I'm going to go. I'm going to get rid of the magnetic field. So no magnetic field. So let's get rid of the magnetic field and instead start at a point and end at a point. And then we'll have a velocity too, a velocity vector, but that's fine. Okay, so let's get rid of the magnetic field. No more magnetic field. I hope you saved that part of the code. Deleted it. Delete all this. Delete. 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 If you have to say delete too, just so you know. Okay, so I don't have any more. Now up here, I'm going to pick a starting point and an observation point. Let's just run this to make sure that I didn't break anything, because sometimes I do. Okay, that's good. Runs. So let's pick a starting point. I'm going to call it P1. P1 is going to be, it's going to be in the same place. Vector -2, 0, 0. And then I'm going to pick an observation point, OBS. It's going to be vector 2, 0, 0. It's the same thing. Same thing. Okay. Now, with that, I'm going to calculate a velocity unit vector. I need to know the direction. So it's x direction. Let's just go ahead and change this to 2.5. So it's not there. And let's put a point there so we can see what these look like. P1P is sphere, position equals P1, which is a vector. Radius is 0.03, picking a value. Observation is also a point. It's a sphere. Position equals OBS, which is a vector. Radius equals 0.03 also. Now I want a unit vector. I'm going to call this V1 hat. It's going to be norm OBS minus P1. So OBS minus P1 is a vector from P1 to OBS, and norm takes a unit vector. This is important because this tells me the direction I'm going to move my points, right? Does that make sense? Okay. Now let's see what I'm going to do next. Now I'm going to pick, I'm not going to use dx. I'm going to use ds. So I'm going to say ds right there. And I'm going to say s, because I'm not moving in the x direction. I'm moving in the s direction. And s is actually going to be 0. I'm going to start at the beginning point. I'm not starting at an x value. S equals 0 is a parameter. I'm parameterizing the path from P1 to OBS. And so S is my parameter value, and ds is how far I'm going to move. Okay. So now down here, I want to calculate my E value based on S, right? So I'm just going to change this to S. And I'm going to say this is while S is less than mag P1 minus OBS. So it's the whole distance, right? I'm going to go from S to S. I'm just making the arrows here. Okay. So that's fine. E0 cosine 2 pi ft minus 2 pi s lambda. But what about the position? This is not going to work. So let's get rid of this. I'm going to say the position is P1 plus S times V hat, right? S times V hat is my, yes, that's a vector with the length of the parameter value in the direction that I want to go. I did call it V hat, didn't I? I called it V1 hat. Why did I do V1? That's fine, whatever. But the rest is the same. Okay, let's just run that, and then I'm going to add my S is S plus ds, and that's my parameter. And let's just comment all this. Let's not worry about this yet. Let's just make sure that this thing works. So comments in Web VPython, you can do this JavaScript comment because it's actually JavaScript. And see, good thing I checked, huh? Because it didn't work. I can't find p here. That's an easy one to fix. Typo. There. Okay, still problem. OBS minus unidentified. Did I like... What did I do wrong? Is there stuff down here that I... No? OBS is not a function. Oh, well, you know what I did? It drew that one. OBS, okay. I called it the same thing. OBSP, that's my sphere. OBS stands for observation. There we go. Look, it worked. Okay, I do want to, let's make the electric field come out of the page because I want to look at it from the top. So that's easy to fix. So down here, I'm just going to have that in the Z direction. So 0, comma, like that. And then I need to change it down. Oh, I didn't time it yet. Okay, there we go. That's what I want. Now I want to do the time thing. So down here, what do I need to change? I need to get rid of that. I need to get rid of that. ET and EA, that's fine. This is fine too, but now this is not fine, right? Because I need to calculate, I need to know the parameter position of each thing, which I don't have, right? I don't have where it is. I did that only once. So I'm going to go cheat. Up here, what I'm going to do is I have my S value. I'm going to go up in my declaration of an arrow and put S equals S1. And I'm going to change this. That's why I did that. S1, S1. I think you could do S equals S. S1, as for its 0.1, S1. So I'm assigning a property to my electric field arrow called S. And so now I know it. I've stored it when I made my arrow. I could go back and call that when I go to calculate the electric field. So down here, my electric field, I need to know that S value. So I can say ET.S. ET.S is the parameter space along that wire. That's my X value, even though we're not in the X direction. And I think everything else is the same except this. I do want this in the Z direction. I think that's the same. Let me just check right here. Yeah. No. Let's see. E. Yeah. Let's see if it works. And it did not. Can't find variable S. Okay, so S1, S1, S1 didn't change that. S1 didn't change that. Dummy. Okay, I think that's it. Boom. Like it. And we're looking at it from the top. You can rotate that around if you want. Okay, so I can make this point in any direction now. I can make a electromagnetic wave line arrow thing in any direction, because all I need is P1 and OBS, and the rest you'll figure out, and I'm pretty happy. So let's save this. I'm going to give you a link to the code. Save. And that's it. Now, I am going to make another video, I hope, showing interference between two waves, but now I can draw at least one wave, and it should be able to easily draw another wave. Great for visualization. Hope that helps. I had fun. Hope you had fun too. I'll talk to you later.